Hello dear students, I am Chinmoy and I'll be with you with your A-level physics exam preparation, and I'll be with you with all the chapters including all the topics and all the questions that might come in your exams and all the thoughts and all the concepts. We'll be building together all the concepts by understanding them thoroughly and also practicing them point by point so that any type of question that comes in your exam can be cleared by you. So without further ado, let's start our lecture. Lecture number 1, we'll be studying physical quantities and units. Today we'll be studying about quantities and the introduction of scalars and vectors. So at first, let's see what are quantities. Quantities are things that can be quantified. So let's write that quantities are things, physical things that can be quantified. For example, you can quantify your mass, right? So let's say my mass is about 65 kgs, your mass might be about 80 kgs or 50 kgs, whatever. So you can actually quantify, or you can actually quantify the speed of a particle or the velocity of a particle, the force on a particle, the torque experienced by a particle, and etc. etc. We will be studying all these in our lectures in upcoming chapters. But what are the things that we can't quantify? Like our emotion. We can't quantify our emotion, right? So emotion is not a quantity, right? So there are physical things, there are abstract things that can be quantified. So those are not quantities. So in physics, we study only on quantities that can be quantified. So any other thing like the emotion or the sadness or the happiness, that cannot be studied under physics, right? So that's our scope of our study. So then what are quantities? We just gave them a definition, but how are they those, or what are the or should I say classifications? So there are two types of quantities. Two types. Okay. So I'll be clearing each of them. So let's start by those quantities that have only a value, not a direction. So there are quantities with values only. And also there are quantities with both value and a definite direction. Okay, let's make things easier for you. Quantities with value, likewise in those examples, mass only has a value. Let's say this person has a weight of 100 kgs. Okay, his mass is 100 kg, but it has only the value, not any direction. We can't say that in the right direction he has mass of 100 kgs and in the left direction he has mass of 50 kgs. That's not possible. His mass is 100 kg and it doesn't have any direction. So there are things that's not directed, like time. Time doesn't have any direction, right? So mass, time, let's say I am giving you a lecture for 15 minutes. So time 15 minutes, it doesn't have any direction. So these types of quantities are called scalar quantities. What are they called? They are called scalar quantities. Scalar. So quantities with values only are called scalar quantities. Scalar quantities. Okay? And our topic of interest is the next type of quantities that have both value and a definite direction. This definite word is super important here. I'll clear you about it in a few minutes. Why is definite is super important? Let's say this car, there is a car, right? Let's say there is a road, and on this road a car is passing by. Okay, so this car has a velocity of 5 meters per second. What does this mean? This means this car is going in the rightward direction with a velocity of 5 meters per second. And in this velocity, there is a value and also a direction with it. Which is the direction? Rightward direction. I am not saying this is going in the leftward direction, right? I am saying this is going in the rightward direction. Correct? So these types of quantities are called vector quantities. Okay? And there are lots of vector quantities like velocities, like acceleration. So I am just making a note of them right now. Velocity is a vector, like acceleration is a vector, like force is a vector, like momentum is a vector. We'll be studying each of them in the upcoming lectures. So don't worry about them if you don't understand each individual. Okay, so these are called vectors, things with both value and a definite direction. Just remember one thing, if you don't give the vector quantities a value and a direction, this can't be a vector. A direction has to go with it always, and if not, that's not a proper vector. Okay, so if you think these are tough things, don't worry, let's make things more and more easier. Okay, so here is a nice example for two types of measurements. The first one I'll be talking about is distance. Number one is distance. And number two I'll be talking about is distance and displacement. Okay, I'll be talking about displacement. Okay, just be attentive right now. See, there is a path that's colored in red. Okay, this path is followed by an object. Let's say an object goes through this path. This object, like the green object, okay, is going through this path. It can be any path, like from your home to your college or school, whatever you might say, anything, right? In physical world, we every day, like if we go outside, we cover a distance. That's a path, right? So let's say this path is about 100 meters. Okay, this path is about 100 meters. This is called displacement. No, this is called distance. Okay, this is called distance, the path that we actually follow. Okay, so distance is the path that any particle actually follows. Okay, that's the distance. Okay, so this distance can be like from your home to your school, from one city to another city, from one country to another country, whatever it might be. That's called distance. And what you might know or what you might notice from this that there is no particular direction for it. We are just telling you that this distance is 100 meters or let's say 100 kilometers, but it doesn't have any direction associated with it. Okay? The actual path is 100 meter or 100 kilometers long. Okay? But we don't say any direction. So distance is of course a scalar quantity. That's a scalar thing. Okay? It doesn't have any direction. So I'll just write it here. It doesn't have any direction with it. Does not have any direction. But if we think about something with direction here, let's say I'm telling you to start from here and end in this position. See, this distance or the path leads you to this position, right? Let's say this is position A and this is position B. So the path rides you through B. But what if I say you are going from A to B, and that's correct. And what if I say in the map that you are going from the north to the making an angle 70 degree from to the right of north, right? Making an angle of 70 degree to the right of north to this finishing position. See, this line that joins it, this line that joins the starting position to the finishing position, this is called displacement. So let's say any car is going like 100 meters here, but the displacement is a measurement from the start to the very end with a straight forward line. So whatever we can say right now, that displacement it is the straight line. It is the straight line from start, which is A, to B, the end, which is B. Okay? Don't worry. After a few more slides, you'll understand every bit of it. Okay? I'll make you understand everything I have told you right now. So, see, point number one, this displacement is straight, and also this displacement should have a value, right? It can have a value. Just put a scale here and it will have a value. Why not? It will of course have a value. Let's see, let's assume this value is about 60 meters. So I can tell you the start position, from the start position, the ending position is 60 meters away. So it has, what does it have? It has a value. So it has value, right? And what does it also has? See, I can tell you to go from the start position at 60 meters to 60 meters at any direction, right? I can tell you to go from, likewise, from here to 60 meter, right? But I didn't tell you to go there. Also, I can tell you to go 60 meters. You might go this way, 60 meters. You might go this way, 60 meters. All are 60 meters. But what's the point? You are not getting to the right destination. So to get to the right destination, I also have to tell you about the angle or the direction of it. If I tell you from north, if we go eastwards 70 degree and go 60 meter, then we will finish at the right position. So it also should have a direction. So it has value and a definite direction and a definite or specific direction. Okay. So this quantity, this displacement has a value and a direction. And what should we call this? A vector, like we told earlier. So this is a vector. So hopefully, for a start, you are starting to learn or distinguish about scalars and vectors. Scalars are values only that can be to any direction, but vectors are value and a specific definite direction. Okay, sorry about my English. I am not a native English speaker, so you will get used to me, right? Okay, so let's have a practice. Okay, see, you can see about different types of paths between town A and town B. Let's think of it as a Google map. So from town A to town B, you can just go there like in this path, right? You can go from town A to town B through this path. This is 4 kilometers, it's given, and you can go this path is 12 and you can arrive at town B. So from whatever we can tell from the picture or the figure, from town A to town B, what's the total displacement here or the distance here? See, the distance, which is a scalar quantity, it should count all the path anyone has to go. So anyone can go there to this point 4 kilometers, so it's 4 plus, and from this point to town B it's 12 kilometers, so it's 16 kilometers, right? That's the distance. And how about the displacement? The displacement is, see, from point A or town A to town B, you can just give it a straight line and it says it's 10 kilometers and that's the displacement. There is nothing else to worry about it. So it's 10 kilometers. And from these calculations, you might notice it that the displacement is less than the distance, right? Well, there is a catch about it. Displacement or distance can also be the same. How? If think like if there is a road, straight road from town A to town B, then the distance would be exact 10 kilometer and also the displacement is 10 kilometer anyway. So both of them are same. So sometimes the distance and the displacement can be equal. So we have to write it about like this. Displacement is less than equal of distance. Okay. So let's just make you remember displacement is a vector quantity. This one, the black line, and distance is the scalar quantity. Okay. Okay, let's go. Now we'll just learn a bit extra right now. Okay. See, I can tell you about the same thing here, but I won't tell you like that. I'll tell you differently right now. Okay. So someone is going from point A or the place A to point C or place C on the map, and the path is through B, right? From A to this curvature of a path, and then to from A to B and then to C. Okay. So if I tell you to calculate the distance, you'll just do it very easily, right? Just do it. You'll just do it very easily. That's not my point actually here. But anyway, let's start with it. Distance is 8 plus 7, and that's 15 kilometers. Okay. And what about the displacement? Let's see what's the displacement. Displacement is, see, from A to point C, you can just give it a straight line, and that's 10 kilometers, right, given here. So 10 kilometers. I guess you have gotten like 2 nanoseconds old enough to understand this. Now, what I am about to tell you is that let's play with time right now, okay? Let's associate time in these calculations. Let's assume the time taken for a person to walk from this point to this point is, let's say, 2 hours. Okay, I'm just assuming any value right now, the time. So I can actually do 2 things. I can just identify the rate of distance covered. Okay, so let's see distance by time. What I am calculating is that how much is the rate of distance for that person, rate of distance covered. Okay, so distance is 15 kilometers divided by 2 hours, and that's 15 by 2 or 7.5 kilometer per hour. So the person is actually walking 7.5 kilometers per hour. Actually, he is not walking, right? It can't be. Well, let's assume. Okay, that's the thing about physics and the maths. You can assume anything, but that's not practical, right? 7.5 kilometers per hour. Or is it? Maybe, or maybe not. Let's don't worry about it. Okay, and also let's talk about something else, but leave some space here. Okay, I'll just write something here. So let's talk about the rate of displacement. Displacement by time. Okay, so let's see. The displacement is 10 kilometers and the time is 2 hours. So it's 5 kilometers per hour. So these are not the same thing, right? How can it be same? Things in the nominator or numerator is the different things. So distance and displacement are not same thing. So these are of course different, but what should we call them? Even, and I might suspect many of you know this. If we just calculate the rate of distance, it's called speed. Speed of a particle or speed of a man or speed of a car, anything. So speed is of a physical particle, right? This is called speed. So speed is actually distance by time. And the rate of displacement covered by a particle is called velocity. Okay, so velocity is the rate of displacement and speed is the rate of distance covered. Okay, so these are 2 different things. So see, if I just tell you the distance doesn't have any definite direction, that's why speed won't have any definite direction, because direction is nowhere in this equation. But for displacement it has a definite direction, this one. So speed, or sorry, velocity will have a definite direction here. So the direction of velocity is on the same direction as the distance. Remember that. It will be handy for us in future. So the direction of velocity is the same as the direction of displacement. So whatever we have covered, let's summarize. So to do a proper summary, we'll first get you to speed, which is distance over time. So we write it by v equal to s by t, and if you just try to understand the unit of it, see, s has a unit of meter or the distance, and time has a unit of seconds, right? Unit is seconds. So the unit is meter per second. But as direction or the distance is a scalar quantity, let's write it this way, as distance is a scalar, speed is also scalar. Okay, done? So speed is a scalar quantity. Let's talk about velocity now. So I'll put a barrier between these two to differentiate them. Okay, so velocity is the rate of displacement, right? Don't forget these two things. Okay, so we also denote them by v, but as this is a vector, we put an arrow over it. Okay, whatever we write as a vector, we have to put an arrow over it to express it as a vector, and the displacement we express it as arrow over s, that's a vector, and time is a scalar. So, and it also has unit of, if you measure it, unit of meter per second, right? So meter per second. And let's finish it by writing as displacement is a vector, velocity is also a vector, right? Okay, done. So will these things come in the exam? Not in this way. Okay, there might be some numerical examples or questions in your exams, so it's better if we solve them right now to cover all the things up. So in this moment, from starting this moment, we'll solve these questions. So if you are doing this class, I might suggest you to pause the class here and just write the question in your note. Remember, whatever you study, try to make a note with it, because the note making capability will increase your memorizing techniques, and you will feel confident about it before the exams when you revise it. Okay, so try to maintain a note of everything that you are studying. Okay, so I might suggest you right now to pause this and make a note of this question, and then we'll just try to solve it together. Okay, so an aeroplane flies a distance of 1150 km from London to Oslo in 1 hour and 30 minutes. Okay, the return means from Oslo to back to London, right? Return journey follows a different flight path, okay, and covers a distance of 1300 km in 2 hours. calculate the average speed of the aircraft and its average velocity over the two trips. Okay, and that's actually an easy question, not a difficult one. So let's say London is here, and let's say Oslo is here. Okay, Oslo, right? Oslo is here. So for the first journey, let's assume, you can assume anything right now because they haven't given to you the path. You can assume any path. So let's assume the flight path is this way, and we are assuming it easier, right, for us. And this flight path covers how many? 1150 kilometers. 1150 kilometers. So let's see, that's S1, okay? And the time taken is T1. Let's say it's 1.5 hours, right? So 1.5 hour, we might write it this way. Does anyone have a confusion about it? 1 hour and 30 minutes means 1.5 hours. Okay? So this is the first flight. But the return flight has a different flight path. See, that's written there. Follows a different flight path. So let's say the flight path is this way. Okay, the flight path is this way, and covers a greater distance. Okay, it's 1300 kilometers. So S2 is 1300 kilometers, and the time taken, let's write the time here, T2 is 2 hours, right? Yeah, 2 hours. Okay, what happens next? Now we have to calculate the average speed of the aircraft. Okay, first of all, if we calculate the average speed, see, whatever the speed or velocity is, speed means distance over time. So speed or average speed, we can call it V bar. See, this bar is a vector. This bar means average. Okay, it's the summation of distance over summation of time. Always try to remember. That's why it's called average, because there are two paths, right? That's why they're calling it an average. But the concept is the same. Distance over time, sum those distances here and sum those times here, and you are good to go. Okay, the first distance is, okay, let's just try write it this way. It's S1 plus S2 and time 1 plus time 2. Okay, now, so 1150 plus 1300 divided by, the times are 1.5 hours plus 2 hours. So let's see what happens. We might get a calculator here and calculate it with your calculator, and it's 700. Nice value, lucky 700 per kilometer per hour, right? So that's the average speed. I hope you guys understood it. And then what's the average velocity? Here is a catch about velocity. Okay, so the velocity average, this arrow is for the vector and this bar is for average. Okay, now just remember this thing. The displacement is from the starting position to the end position, okay, over a specific time. Right now you are calculating the overall, through the overall time, right? You are calculating for 1.5 hour and 2 hour overall, right? So you are calculating the whole thing, 1.5 plus 2, so 3.5 hours you are calculating it for. In this time, what's the displacement? See here, the displacement, what we call the S vector, and under it is the summation of t, the summation of the times together. The S vector right now, how much is it? See, London is the starting position right now for this flight, start, and London itself is the end position. So, from where the flight started is where the flight ended, right? Overall. That's why it has no displacement at all. See, in the previous examples, if we started here and then reached all the way, like this one, follow me. If we started here and reached all the way at the end at A position itself, the distance will be something, but the displacement will be 0. We are ending at the same position. That's why the displacement will be 0 here, okay? It will be a nice 0, and by time, the total time, whatever you might call it. Now, if something is under 0 or 0 is divided by something, it produces a 0. So, average velocity is 0. So, whatever the flight is doing, its average velocity is 0, though it has average speed, because speed is not a vector. It is scalar, that's why it has a value. That's 700 km per hour. But for velocity, it's 0. Okay, so be a little bit careful while you are calculating the average velocity or velocity overall. Okay, so that's the point here. Now we have another type of mathematical problem, I might call it. So do the same thing, pause it right here, just take it into your notebook, and then we'll study together. Okay? Okay. If we start the problem, a hiker walks 5 km due east and then 10 km due south. So you might as well have the proper idea of a map. So anyone should have this proper idea of a map because you are using it every day, right? The Google map or any other form of map, the Apple Maps or anything. See, if we draw any map on a sheet of paper, we call the upper thing or the upper arrow as north. So the lower is south anyways, and from this position to the right is east and to the left is west. So you have to remember it, okay, for these types of maths. A hiker walks 5 km due east. So a hiker is going, so just follow this line, 5 kilometers here, okay. So let's say it's S1, 5 kilometers due east, and then 10 km due south. So from this position, okay, I'll just take it like that. Let's make it a bit, yep. And then 10 km due north, okay. So this is 10 kilometers due north. Okay, nice. S2. Draw a scale diagram to calculate the displacement of the hiker from the starting position. So we have actually drawn the diagram here, right? So draw a scale diagram to calculate the displacement. So we have to carry out the calculations for displacement. So what is the displacement here? So this is now question number 1, right? What is the displacement? Remember, displacement is a vectored quantity and it represents a straight line from start to end, right? So the straight line is from start to end, and that's the displacement, the pink line. Okay, so the start position is here, start, and the ending position is here. Okay, so we have drawn it, like let's calculate it. So the displacement, let's say this is A, this is B, and this is C. So the displacement is AB, right? AB. Now if you remember Pythagoras' theorem, you might remember it from maths, right? This is S1 square plus S2 square. S1 is, how much is it? 5 kilometers, 5 square, and S2 is, how much is it? 10, right? 10, yep, 10 in kilometers. So whatever this brings you, root over 5 square plus 10 square, it's 5 root 5 or 11.18 kilometer. That's the answer. Okay, that's it, nothing else. Now question number 2, calculate the average speed and the average velocity of the hiker if the complete journey took 5 hours. So you know it right now. So average speed, V is, let's just partition our board here. Okay, so summation of displacement, or sorry, distance, right? Speed has distance on top and summation of time under it. Okay, summation of distance is S1 plus S2 and summation of time is just, it has told us just the overall time, right? Summation of t. So summation of S1, S1 is how much? 5, S2 is 10, and the total time is 5 hours. So the unit, you have to be careful about the unit here. This is kilometers and this is hours. So the unit will be kilometer per hour, right? So 5 plus 10 means 15, and then if we divide 15 by 5, that's 3 kilometer per hour. So it's 3 kilometers per hour, right? Now average velocity. So velocity vector, and this is S by t, right? S means the displacement and t means time. How much is the displacement? Is 11.18 or 5 root 5, was it? How much was it? Yeah, 5 root 5. I might just write it like that. That will be easier for your eyes. And that's, time is 5 hours. So it's root over 5 kilometers per hour. Okay, that's it, nothing else. So the questions are very easy to understand and to implement in your exam halls. Okay, let's do one more question and then our class will be done. So the earth orbits the sun at a distance of, oh my god, 150,000,000 kilometer. How long does it take light from the sun to reach the earth? Very nice question. And that's a more practical question, right? So earth, that's our planet right here. So it, like, fill it with green. and sun, there's a bigger thing, of course bigger, and much more bigger, okay, much more bigger, but you can just draw it. So I'm just drawing it anywhere like that, and this is sun. So this is sun and this is earth. Each moment light is coming from the sun to the earth, right? Each moment. So light rays are coming in this path, see, and this is the distance covered. You might also tell it as displacement because it's straight line, whatever it is. Let's call it a distance, okay? This distance, or S, how much is it? This distance is 150, oh my god, 000 kilometers, whatever it is. Be careful about the zeros here, okay? And the speed of light, you have also got to know the speed of light, right? The speed of light is, let's say that's, sorry, let's take it in this, draw it with this arrow, the pink arrow, the velocity or the speed. This is speed of light in space is 3 into 10 to the power 8 meter per second. And that's a general knowledge, right? So we have to calculate the time, right? Now you know that displacement, or in this case distance, S equal to V by T. Or is it? Is it? No, of course not. Speed equals to distance by time. So time equal to speed by velocity, or in this case, you can go it for either way because there's the straight line. So here distance and displacement are the same, and velocity and speed will have the same value. So S, how much is S? 150, 000, and 000, and that's kilometers. So you have to convert it to meter. That's this much of meters divided by the speed is 3 into 10 to the power 8 meter per second. So this meter and this meter cuts themselves, they are eliminated, and this whatever remains is the second, right? So calculate it. 150,000,000 into 10 to the power 3 divided by 3 into 10 to the power 8, and that's 500 seconds. If you go by minutes, it's like 8 minutes and 20 seconds. 8 minutes 20 seconds. That's pretty much their real value. So whatever we see, that's the fun fact about the light we see from sun. Whatever we see, if you look at the sun from your eyes, you are watching the past of sun. You are watching it 8 minutes later. See, you are not watching the light instantly, right? It's taking time. It's taking 8 minutes and 20 seconds to reach your eyes. So you are just watching the past. And whatever we watch, like I'm watching the pen, I'm also watching its past, because the light takes a little bit of time to reach my eyes. But there is a catch. The catch is light is too fast. So for this pen, from this pen, if any light just reflects to my eyes, the time is near zero or zero. But from Earth's point of view, from the sun, this is a huge amount of distance to be covered, and it takes time. So whenever you are looking at the sun, just remember, you are watching its past, not the present. Okay? You are 8 minutes slow while watching it. Okay? Okay, that's my lecture. The first lecture, we have just covered scalars and vectors, not fully though. We have covered the applications or the examples of distance, displacement, velocity and speed. Okay? And I'll be happy to answer any of your questions in the comment box if there is any, and meet you in the next lecture. Okay? Goodbye.